positive infinity all the way to 2, inclusive of the 2, because of the equal sign, because of the little equal sign under here, equals 0 works. And then again, union that with 2.5, or 2.5 or 5 halves or whatever, all the way to positive infinity, because this other side works from 2.5 all the way to positive infinity. Also works for what we want. Ta-da! Then number 14, very similar process. I won't take you through the whole thing. The idea is, though, we're going to factor this out to make it maybe a little easier if we get the chance here. If we can get some linear factors, this will simplify things a lot. What goes into negative 48? So that'll be like a minus 6 plus 8. And so then our solutions would be something like x equals 6 and x equals negative 8. Those would be what makes it equal to 0. And so we have a negative 8 here on the number line and then a positive 6 occurring later. And we need to try numbers that are around them, you know, on the number line. So a 0 would be a good test point between negative 8 and positive 6. You could also try a 7 over here. That's a 7. And then something like negative 9 or negative 10, whatever seems easier to work with you over here. And then just try those. And remember, we don't have an equal to 0 part, so these things are not in the solution set. When we got stuff, it'll be parentheses, or parentheses that way, or whatever. But it won't be boxes, because there's no equal to sign. No box. Anyway, watch out for that. Same idea. What else? Okay, number 15. We have absolute value of this mess equals 59. So remember, that means either 7v negative, take away 10, equals 59 in the first place, or negative 7v minus 10 equals negative 59, because those are the only two things that absolute value to 59. And we just solve them both. And so this one, if we plus the 10, 59 plus 10 is 69 divided by negative 7. And so we'll just end up, if I did that right, that's 69 over 7 negative. That's one of them. And then this one will have, this one's nicer. Negative 59 plus 10 is negative 49. So negative 49 over negative 7, that's going to be a nice number because that's negative 49 over negative 7. The negatives will cancel, and you get yourself a positive 7. Cool. Similar idea. This one, we're just going to say, I mean, it's just decimals. I won't do the whole thing for you, but it's x minus 6.8 equals 4, or x minus 6.8 equals negative 4, and you just kind of, you know, plussing the 6.8 over to each side, and be careful with your negatives, because that's what throws everybody. This final, okay, so, okay, it's not number 3. Okay, number 17 here. Okay, we have that the absolute value is less than or equal to 4. Absolute value is less than or equal to 4. So we'll have to remember what that means. If the absolute value is less than 4, that means it's like 3 or 2 or 1. So this is some number that is not very far from 0. It's less than 4 steps away from 0 is what that means. So we're going to say that v minus 2 is either less than or equal to 4 like it says, or, let's see here, no, it'd be and or something like that. Let's think about that for a second. V minus 2 also, we also have this condition. It seems like if v, okay, so if it were less than 4 steps to the right, we'd be less than 4. If it were less than 4 steps to the left of the number line, I'm thinking it's greater than or equal to negative 4. Greater than equal to negative 4. Sorry for the mess. We'll solve both of those. If we have this minus 2, we'll plus it, so that's v less than or equal to 4 plus the 2 is 6. And then plus the 2 here, so we have v greater than or equal to negative 4 plus 2. Negative 4 plus 2 is negative 2. And so now we have bounds here that our v is greater than 2, greater than negative 2, less than 6. It's kind of sandwiched between the two of them. And so with this kind, when you start out with a less than on the absolute value, it's kind of more like an and situation. We get to say, well, our v values are stuck between the two. And so we can say v is less than or equal to 6 like we were saying in the first place, but it's also bigger than or equal to negative 2, and so we sandwich it between them. It's between negative 2 and positive 6 on the number line. Then last couple here, last few anyway, Number 18, we're just graphing the line, so that's -4 is our slope, or sorry, y-intercept, so -4 y-intercept, and a slope of -1/3, so that's down 1 over 1, 2, 3. Sorry for the focus there. Down 1 over 3, and then call it a day, or you could do up 1 and back 3 if you like that better. And then, let's see here, this one is also a straight line graph. We can graph it, you can either turn it into mx plus b, or you can graph it using intercepts by plugging in zeros if you like. If I plug in a 0 for x, then that'll zero out, and we'll have just 5y equals 5, and if 5y, what some people do is they just cover it up. 5y equals 5, and 5 goes into 5 one time, so the y part would be 1. So we'd have first dot is at 0, 1, so 0, 1. And then our second dot, if I cover up the y part, because I plugged in, say, a 0 for y, 5 times 0 is 0, so that basically covers up the y part. Here, we'll use a skinny little finger. Whatever, we use the pen. Hey, I don't know, whatever. Anyway, so then 6 times something equals 5. 6x equals 5. And so then dividing that 6, that's 5 over 6. That's weird, but whatever. So 5 out of 6, 5 out of 6. So that's 5/6, this, whatever, is 0. So then 5 out of 6, 0. We're going to estimate it that way, probably. And so now we have ourselves some kind of a line like this that goes through the 1 dot on the y-intercept, and then has a slope it's essentially some kind of a 5 out of 6 negative slope if you look at it, but whatever. Anyway, it's these two dots, or you can do it another way if you like. And then write the point slope form of the equation through the points here, and so remember, let's figure out the slope between them. -5 take away 5, and then the x's will be 0 take away -5, so it's -5 minus 5 is -10. O minus 5 is like O plus 5, so that's 5, so we have a -10 over 5, or a -2 slope. And now we'll say, to generalize, our line will be the set of all points such that if I take the slope between -5, 5, and any other xy on the line, any other dot on the line, then the slope is still going to be -2. And so we'll say, real quick take on it, y minus 5 over x take away -5, oh, double negative, take away -5, should still give me a -2 slope if this xy is really on the line. So for any xy on the line, I should be able to do this minus that and this minus that and still get a -2 over 1 slope. Ta-da! Sorry, that wasn't on the screen. Maybe clean up the x plus 5, and then remember, we're going to also clean up the fraction a little bit so we don't have any undefined issues, and I'm going to times this over there. And so that'll be, the official form will be y minus 5, still here on the left. This part will be gone, so we're moving it over there. So we'll keep the -2 equals -2 on the right-hand side. And then equals -2 timesing with this one, we're timesing it out so that it's not a fraction there anymore. Because when you have fractions, you can have something going undefined, and that it puts a hole in the line. Because if I put a -5 in for x, -5 plus 5 would be 0 on the bottom, and that's a mess, and that's not an issue if we write it this way. So there is one form of the point slope version of the line, or however you want to say that.